Question 19. 3 fair 6-sided dice are rolled. Find the probability that the total on all 3 dice is 5 or less. So the total on all 3 is them added together, I'm assuming. Might be good to just do a sample space here. The first dice, the second dice, and the third dice, right? They can all be 1. We would add up to 3. We start and leave the first dice as a 1. We can have a 1, 2, 1. We can also have a 1, 1, 2. We could also have a 1, a 2, and a 2. We could also have a 1, a 3, and a 1. And a 1, a 1, and a 3. They're all different orders. Okay, I think that covers the 1s. If his first dice is a 2, the second dice could be a 1. And the third dice could be a 1. Or a 2 and 2 1s. So we could have a 2, 2 and a 1, or a 2, a 1 and a 2. That's still less than 5, or 5 or less. And that covers the first dice being 2, because the second one is a 3, that's 5 already. We wouldn't have a third one. And then can the first dice be a 3? We could have 2 1s, and that's it. So I think that covers all probabilities. How many are there? 6, 3, and 1, 10. Over the total amount of outcomes, 6 to the power 3, which is 216. So 10 over 216 is the probability of this happening. Question 20. The soccer team has 5 penalty takers for the penalty shootout. Each of the 5 has to take 1 penalty, and the probabilities for each player's success are given by the following table. 0.9, 0.8, no, okay, it's going down and down and down. The best penalty takers are on first. Find the probability that all 5 score. If all 5 are going to score, we just have 0.9, 0.75, a 5 and a 4. So calculator you use here, multiplying all these out, we get 0.108 for question 1. For part 2, at least 1 misses. Well, at least 1 misses is the opposing part of part A. If they all score, nobody misses. So the chance that at least 1 misses is all the other probabilities that they all score. So 1 minus 0.108 is going to give me 0.9, 0.892. 0.892. They all score except for E. Oh, come on, we just have to multiply. This is too easy for you guys in 6th year. They all score apart from E. So A 0.9, by B 0.8, by C 0.75, by D 0.5, and E misses, so 0.6. If it's 0.4 for them to score, that's going to work out to be slightly higher than the first one, 0.162. They all score except for B. Well, it's just the exact same thing again here. They all score except from B. A scores 0.9. B misses 0.2. It's 0.8 that he scores. 0.2 by 0.75 by 0.5 by 0.4. That's going to give 0.027, 0.027, and then E exactly 4 of the 5 score. Okay, well, there's 4 options there, isn't there, for exactly 4 of the 5 to score? That's 5, isn't it? It's 5 choose 4, which is 5 choose 1, which is 5. So there's 5 options here. So I think we just have to multiply them out. We already have, who have we got? We have E, they all score except from E. They all score except for B. So we have 3 and 4. We just need to add these 2 together and bring in the other 3 possibilities as well. Have we got, what was part No, at least one misses is 108. Okay, so we just have to work out the rest of them. So we have E and B done. So what was the first one? E. That's everyone scores apart from E. Everyone scores apart from B. Sorry, B is this one. Just confusing myself here. So let's look at A. Everyone scores apart from A. So 0.9 is going to be 0.1 that he misses by 0.8, by 0.75, by 0.5, by 0.4. And that's going to give me 0.012. That's A. We've done B. Okay, C. C misses 0.25, 0.9, by 0.8, by 0.25, by 0.5, by 0.4. And that's going to give 0.036. Okay, who else have we got? E, B, A, B, C, D we need. So we need D. Do it over here. So D misses, well, that's 0.5, isn't it? So it's not going to change. It'd be the same odds that they all score. Have we got that? They all score. All 5 scores, put this 0.108. So I've got 0.108 to 0.5, would just give you the same on the other side. So 0.036, 0.012, 0.027, and 0.162. And if we add all these together, 108 and 36 is 144, and 12 is 156, and 27 is 183, and 162 is 345. Just double check that in the calculator. It is 0.345. That's exactly 4 of the 5 score. I don't think there's an easier way to do it. Okay, question 21. Move over here. A university student walks, cycles, or drives to college with these probabilities. If she walks, she has a probability of 0.35 of being late. If she cycles, she's 0.1 probability, and if she drives, she gets stuck in traffic and a higher probability. So correct the 3DP, the probability she'd be late on a particular day. She walked given that she was late, and she walked given that she was not late. Okay, I think the best way of doing this is a tree diagram. So she walks, cycles, or drives. Okay, walks, cycles, or drives. Walks, cycles, or drives. 0.1, 0.3, 0.6. 0.1, 0.3, and 0.6. Okay, so she's either going to be late or she's not going to be late. Only 2 things can happen. So if she walks, cycles, drives, we have it in the right order. So if she walks, she has a probability of 0.35 of being late. 0.35. She's going to be late. So not late is 0.65. Okay, if she cycles, what are our 2 probabilities? If she cycles, the probability of being late is 0.1. 0.1. Sorry, that's not late, that's 65, not late. 0.1 is late, so 0.9, not late. And if she drives, being late is 0.55. Don't drive your car. And then 0.45 for not to be late. Okay, should be late on a particular day. So just add those 3 up. So they are late is this one, is this one, and is this one. So 0.1 by 0.35. Just do this on a calculator in one big line, plus 0.3 by 0.1. Just be careful to put the decimals in, and then add 0.6 by 0.55. And that is going to give us 0.395. So this person is going to annoy their boss. They're late quite a lot, nearly 40% of the time. She walked given that she was late. Okay, the probability she walked given she was late is the probability of walk intersection late over the probability of late. When we have the probability of late down here, this 0.395. So where does walk intersect with being late? Well, walk and late are this one here, aren't they? So where they intersect is 0.1 by 0.35 divided by 0.395. So that's equal to 0.089 is that one. And she walked given that she was not late. So that's the probability she walked given that she was not late. Probability she walked given not late. Okay, where do walk and not late intersect? Walk and not late. This is my intersection. 0.1 by 0.65. The probability that where walk intercepts with not late over the probability of not late, which is 1 minus this guy, so 0.4. 0.605 is 1 minus 0.395. And walked, intercept, and not late is 0.1 by 0.65. 0.1 by 0.65 divided by 0.605 is going to give me 0.107. Hopefully you're mastering these questions at this point.